Good morning, sir. This is Bhavana from CSC section in second year. Here, my problem is one tail test. Here the here the one example for one tail test. If the masses of 300 students are normally distributed with mean 68 kgs and standard deviation 3 kgs, how many students have masses? Here the here we find the questions greater than 72 kgs, less than equals to 64 kgs, and third one we find the between 65 and 71 kgs inclusive. Here the given data mean equals to 68 kgs, standard deviation equals to 3 kgs, total students is 300 students. Here the formula for one tail test, z equals to x minus mu by some mu by variance. Explanation of z score is, and it is used in standard data. Here the steps of here steps we will find the how to calculate the one tail test in briefly. Calculate z scores for each specified mass. Find the corresponding probabilities using the z tables. Multiply by the total number of students to find how many students fall in each category. Here first one we will calculate the greater than 72 kgs. X equals to 72, z score, z equals to 72 minus 68 by 3 equals to 4 by 3 equals to 1.33. From the z table, the probability corresponding to z equals to 1.33 in approximately 0.9082. This is the probability of student having mass of less than 72 kgs. The probability of a student having a mass greater than 72 kgs is the the cumulative probability for 72 kgs. P of x greater than 72 equals to 1 minus P of x less than 72 equals to 1 minus 0.9080 equals to 0.0918. So here the 9.18% of the students have mass greater than 72 kgs. There are 300 students in total, so the number of students with mass greater than 72 kgs, 0.918 into 300 equals to 27.54. Rounding the nearest whole number, approximately 28 students have a mass greater than 72 kgs. Here x equals to 64, z score, z equals to 64 minus 68 by 3 equals to minus 3 equals minus 4 by 3 equals to 1 minus 1.33. From z table, the probability corresponding to z equals to minus 1.33 is approximately 0.0198. The number of students with mass less than equals to 64 kgs, 0.918 into 300 equals to 27.54. Rounding to the nearest whole number, of approximately 28 students have mass less than or equals to 64 kgs. Calculate the z score for 65 kgs and 75 kgs. Here we'll calculate the between 64 and 71 kgs. For this part, we need to find out how many students a mass between 65 kgs and 71 kgs. We'll calculate the z score for both 65 kgs and 71 kgs. For x equals to 65 kgs, z equals to 65 minus 68 by 3 equals to minus 3 by 3 equals to minus 1. For x equals to 71, z equals to 71 minus 68 by 3 equals to 3 by 3 equals to 1. So the z score or for 65 kgs equal 65 z equals to minus 1. For 71 kgs, z equals to 1. For z table, for the cumulative probability for z equals to minus 1, cumulative probability is approximately 0.1587. For z equals to 1, the cumulative probability is approximately 0.8413. Calculate the probability between 65 and 71 kgs. The probability of a student having mass between 65 kgs and 71 kgs is the difference between the cumulative probability for these two z score p of x less than equals x less than to 71 equals to p of z minus 1 minus p of z equals to minus 1 equals to 0.8413 minus 0.1587 equals to 0.6826. So 68.26% of the student have mass between 65 kgs and 71 kgs. The number of students between 65 kgs and 71 kgs is 0.6826 into 300 equals to 204.78 kgs. Rounding the nearest whole number, approximately 205 students have a mass between 65 kgs and 71 kgs. After calculating the number of students each part, student with mass 72 kgs 28 student with mass less than equals to 64 kgs is 28 student with mass between 65 kgs and 75 kgs is total student is 205 students. Here the conclusion for one tail test. In this exercise we used the concept of z-score to stimulate to standard the data determines probability by converting the given mass values into a standard deviation. We could use the Z table to calculate the probability of a student mass falling, which is specified range. Finally, multiply this probability by the total number of students use the number of students in each category. Thank you, sir.